Hi, my name is Canalun. Thank you for coming. Today I will talk about prototype pollution. It seems a super niche topic. So, to be honest, I'm happy to meet people a bit more than I expected. But joking. Okay, so let's start. Thank you. I'm canalun. I love browsers, working on Firefox and bug hunting on Chromium. I'm also a security researcher at Cloud Security. So I like memory corruption, but today the topic is not JS. By the way, have you ever seen the code like this? It's from Google Cloud, and document query selector all is overridden. What about it? This replaces the global promise with original promise of Zone.js. It's a famous library of AngularJS. And these replacements of prototype is called prototype override, monkey patch, etc. Then some people say, in some context, prototype pollution. So today I'll talk about prototype override, its basics, current state, then problems. Lastly, desired features. But it's not something like a true answer, just ideas or like basic hints for future discussion of our community. So first, let's warm up before diving into the C. Basically, you can override prototypes in two ways. The simpler one is this, just assignment. So it's trivial and obvious, just assign your special function to prototype. Third-party developer's friend. Then have you suffered from prototype modification in these 5 years? Then 63% answers yes. So actually, we can find many overrides in the wild. Zone.js, Google Cloud, and I.O. I.O. is a library of anti-advertisement. Additionally, this is a personal thing, but I've seen this kind of breaking change. I don't remember the details, but super mysterious changes were there. So very mysterious. I don't remember, but it's actually breaking. Then anyway, there are still prototype override widely, so let's deep dive into that. So what are the problems? The point is each can override the prototypes as they want, then they entangle. Because of this situation, I think 3 types of tragedy can happen. Let's see one by one. First is a contradiction, I call. To begin, I want to introduce an assumption. This is an important assumption, that is, scripts other than any environment. So at least developers of third-party scripts or extension should think so. Because we don't know what happens here. So their script should be like a chameleon. This means the product can exist with any override. It's true even if map prototype set is rewritten. The products have to survive under these situations. Okay, but how? Fortunately, there is a hack. You can get fresh prototype from iframe. Firstly, you create iframe and set it to the body. By doing so, iframe gets window, that is JS context. So you can pick up fresh prototype, clean prototype. It's clean. If you want to get fresh getter or setter, it's also possible. You get them and bind or call helps you. Like this. So you can pick up children, then children is kind of, so anyway, you can use call and bind it. So the problem seems to be resolved. It's totally fine if we can get fresh prototype whenever we want. But, okay, there remains a problem. What if someone wants to force others to use overridden prototypes? I mean, like this. So Zone.js wants others to use its original promise, its unique promise. But third-party scripts want to avoid it. So they want to use fresh prototype. In this situation, they cannot coexist. If Zone wins, third-party script will get broken. Vice versa. If third-party script wins, Zone cannot capture some promises and it will break somehow. So here is a contradiction. Generally, scripts trying to affect the entire system and scripts trying to avoid monkey patch effect cannot exist together. So this is a contradiction. This is the first tragedy, I think. So the second tragedy is collision. I think you can imagine the problem easily. This problem begins with one simple question. What if everyone overrides the same prototype? Yes, it will be conflicted. Collision happens. Of course, some tricks can avoid collision, but it's not necessarily everyone uses that kind of hack. So this patch conflict is a classic argument against monkey patching. As this post says, it's like everyone is a language designer. It's an apocalypse. So is there any solution? Currently, one idea is isolation using the same origin iframe. So again, iframe. You can wrap third-party scripts or extension scripts in their own iframes. This isolates their context from the main page and from each other. You can isolate them. Actually, Salesforce has a library for this called Mirror Membrane. And its documentation states that in browsers, they are forced to use a same domain iframe to isolate code. But, okay, so did you see that? So it mentions shadow realm. So it's a proposal. Then let's see that. Shadow realm is a stage 3 proposal. It's designed to be a lightweight sandbox, an isolated context with its own global object. So you can see the code like this. Create shadow realm, then import function and get it. Get it from this context. You can call it from this context. Also, there's a kind of eval, like red.evaluate. Then you can execute stringified function in shadow realm from this context, from this world. This looks really useful for solving our collision problem. But, okay, again, there's a big catch. DOM and fetch APIs are excluded from shadow realm. Because it's a true sandbox, it can't have side effects like DOM, fetches, so there are many other APIs excluded from shadow realm. This means scripts that need to patch side effect like DOM cannot be wrapped in a shadow realm. They have to override DOM or fetch, so they cannot be wrapped in shadow realm. So even if we get shadow realm, those scripts will remain in the main context and will still conflict. The collision problem is not truly solved, I think. So the tragedy remains. Okay, so let's move on to the third tragedy, attack escalation. Firstly, this code is from a compromised payment page, the famous supply chain attack against British Airways in 2018. Malicious third-party scripts were injected onto the payment page, so you can see the script send the user information to the attacker domain like this. So this is compromised script. So supply chain attack means the situation where malicious code gets mixed into dependencies and does various things like prompting users to install malware, etc., etc. Then, okay, what is the relationship to prototype override? Is if that malicious code can override prototypes, it can capture all on-memory data that passes through the prototype it poisoned. So for example, Just by overriding array prototype includes like this, an attacker can steal data every single time the app uses includes like this. So this is a horrible thing. This can even be used against browser extensions. This is not supply chain attack exactly speaking, but a malicious web page can pollute its own context prototype, and then they are used by an extension's injected script. The data is skimmed by the prototypes. So actually, I've seen this vulnerability in the wild. Like this. The attacker. Okay. So, but regarding this point, if you want to know more, okay, please check it out, the WASP extension cheat sheet. So anyway, the main point is that prototype override is a powerful tool that can be leveraged by attackers in supply chain attack. So obviously, the question is, are there any defenses? So you might remember our earlier trick, getting a fresh prototype from an iframe. If we can always get fresh prototypes, we could mitigate the attack. I mean, we could just tell our transpilers to always use the clean original prototypes. Very hacky, but it's true. But can we really always get a clean prototype from iframe? This is the question. Then conclusion is no. Okay, yes, no, we can't. The reason is, yeah, there are several reasons, but yeah, I will introduce it. The reason is, what is the attacker overrides document create element? Every time our code creates an iframe, the attacker's code runs and poisons the iframe's prototype, like this. So create element is overridden, then document prototype create element is like this. So every time we create iframe, this fires. So iframe.contentWindow.promise is overridden. So if we can't guarantee a fresh one, can we at least check if a prototype is clean or if it has been overridden? Yes, no. No. One simple idea is to use toString. Native functions will return a string containing native code. This is described in the ECMAScript spec. It's designed to return native code for native functions. But what if toString itself is overridden? Actually, Zone.js overrides toString to return a string that looks native, like this. So this is an actual code of Zone.js. It's a kind of trick. Also, JavaScript's proxy feature makes this more difficult. You can wrap a function in a proxy, intercept the code, and toString will still report native code in this case, because the object itself is not overridden. This is the actual result, so it's quite difficult to detect it. In this case, document create element is already kind of overridden or intervented by proxy. So it's an overrider's game. If you want to get a fresh prototype, the overrider can hook create element. If you want to detect an override, they can hide it. So let's summarize. If a prototype is overridden, all on-memory data is in danger. And when it comes to prototype override, the overrider has the advantage. Of course, we have to prevent supply chain attack first of all, but the question arises, there are any mitigation specs? Then we can see secure ECMAScript. It's called SES. It's a stricter subset of JS that excludes mutable premodules. Premodules means built-ins, array, map, etc. Okay, in other words, in secure ECMAScript, prototypes are never overridden. This is implemented in a shim called Endo, which is used by Agoric and MetaMask, etc. So MetaMask, the popular crypto wallet, relies on this. Let's see inside. Especially MetaMask uses a function called lockdown from Endo in the perspective of prototype override as a defense against it. So lockdown is called. Lockdown is essentially a recursively applied object.freeze. Evokes the entire global object, it traverses the global entire object, and freezes one by one, making it read-only. So it looks super silver bullet. But I don't think so. Lockdown is very difficult to use. If you apply it too early, you break libraries like Zone.js that has to override prototypes. If you apply it too late, an attacker might have already done what they want to do. So what about shadow layer? As we said, you can't wrap scripts that override DOM or fetch. The attack surface remains. This means from an attacker's perspective, libraries to override side effects are still targets. Yeah, so attack escalation remains. So far, we've seen the three tragedies around prototype override. So let's recap them. One is contradiction between different types of scripts. One is eager to force others to use overridden prototypes, but the other will avoid that. Secondly, collision on the same prototype. Finally, escalation of supply chain attacks. So based on them, these 3 points, let's talk about what can be added to the ecosystem. This isn't a perfect answer, but just like ideas or hints for future discussion. First, it's an important point, I believe. First of all, we must accept that context-wide prototype override will remain, I think. It's risky, but it's a powerful feature of JavaScript. Actually, some features like observation or hooking rely on this. So things like Zone.js depend on it. So it can be removed from the web anymore. So remember, as we saw in my poll, there is a fact that it's a real problem that annoys the majority of third-party developers still now. It's an evidence that prototype override is still necessary on many occasions. So that means we must live with these 3 tragedies. So I think it would be better to think not about how to eliminate the problem, but how to make it easier to handle these problems. So what if we have these things? Okay, so there are 2 simple ideas. First, an API to get the native prototype whenever you want. And the second, better indicators for when an override happens. Okay, let's look at the first idea. API to get native prototype whenever you want. Whenever you want. This has actually been discussed before in ES Discourse. ES Discourse is a homepage, website, to discuss idea before proposing it as a spec. There are 2 topics were discussed: use initial directive and stdlib proxies from the same person. The use initial directive would create a scope where all built-ins like mathmax are guaranteed to be the original. So you can use the original prototype within this scope. Anyway, you can see this, like this. So use initial, the scope. In this scope, you can use original prototype. So mathmax is now overridden, but getmax returns the correct result. However, this was seen as too complicated to implement, especially from an implementer of engine. So yeah, if nest and nest and nest, and each, so one is without use initial, but one is with use initial, and without use initial, with use initial, etc., 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 and they nested. In this situation, very, very, very complicated to implement. On the other hand, std proposal seems more promising. It would just expose a global map of all original definitions. You can take original, clean prototype from this whenever you want. But we have to acknowledge this would nullify the security model of some libraries, which force other scripts to use their overridden versions. So this is a serious regression, serious compact issues. So I think the first idea is not realistic. So what about the second idea? Indicators for prototype override. So this is, what if we could make the status of libraries more transparent? Okay, if we knew what the library overrides and why, maybe it would be easier to decide how to handle it. So nowadays, we don't know exactly if this library overrides something, but if we can, I think a little bit better, situation is a little bit better. So, for example, is it okay to cache it in shadow realm? For example, is it okay to use this with that libraries? So transparency helps us to avoid tragedies, I think. More easier handling can be realized. So for example, I don't know it's possible and appropriate, but this could be an NPM audit entry. Library authors would declare what they override. This transparency would help developers avoid conflicts, I think. Of course, yeah, malicious libs will disguise it, but it doesn't directly increase the attack surface. So I think this is not an issue. And let me introduce other ideas. So there are other discussed ideas also. For example, Gal Wiseman once discussed unique CSP directive in the presentation, The Same Origin Concern. So you can see this directive, CSP run on same origin realm. Then this directive prohibits to get fresh prototypes from iframe. So it basically gives the advantage to web page author. This is the idea. So here, I think we have to consider one big philosophical question. So, like, if we give a big advantage to web page author, the current ecosystem of third-party scripts or extension scripts will, I think, break. So this is a difficult point, I think. So anyway, today we don't have enough time anymore. 30 minutes is too short to resolve this super big problem. So this is today's summary. So let's summarize up today's talk. So prototype override is still widely used and causes real problems, contradictions, conflicts, and attack escalation. It's very difficult to defend against. And shadow realm won't solve everything. But maybe we can improve the ecosystem with more transparency. Thank you, that's it. Thank you.